Okay, let's get started. Welcome, everybody. My name is Brooke Heffrey, and I am director of the CINA Center at George Mason University. I'd like to welcome you to today's kickoff briefing. The project is named Adaptive Graph-Based Framework for Multi-Source Digital Forensic Analysis. And the researchers are Dr. Yao Ma, Assistant Professor, Department of Computer Science at Rensselaer Polytechnic Institute, and Dr. Lu Cheng, Assistant Professor at the University of Illinois, Chicago. Before we get started, I'd like to say a few words for newcomers about CINA. CINA is a DHS Center of Excellence hosted at George Mason. CINA stands for Criminal Investigations and Network Analysis, and our mandate is to counter transnational criminal organizations. DHS Centers of Excellence are managed by DHS Science and Technology Director's Office of University Programs to conduct groundbreaking research resulting in rigorous, objective knowledge products and timely solutions for DHS components. Under this 10-year cooperative agreement, George Mason receives annual funding from OUP under S&T to fund research by scholars at institutions all over the country, and in several cases in allied countries. The challenge areas in CINA's portfolio include criminal network analysis, dynamic patterns of criminal activity, forensics, both cyber and traditional, and criminal investigative processes. Like most of our projects, today's research covers multiple areas, but is most closely aligned with cyber forensics. CINA also has a mandate to conduct education workforce development activities. For example, last summer, CINA hosted 3 summer research teams from minority serving institutions, and we hope to host a number of teams again this summer. We also every summer host interns through the generous funding from the cooperative agreement, and we're looking at our biggest year yet for interns. Mostly placed with our close partners at HSI's Cyber Crime Center and at the Customs and Border Protection's National Targeting Center. So if you, it's a little bit late in the season, but if you're a component and are interested in hosting interns with the support of S&T through CINA, we would love to talk to you. CINA also hosts ongoing events, and we conduct outreach. We have a distinguished speaker series. Recent speakers included Abby Stylianou from St. Louis University on identifying where victims of human trafficking and child sexual abuse are photographed. Just on Tuesday, we had Colton Seal, a former FBI agent who worked with the High Value Detainee Interrogation Group, and he spoke on interview mindset. If you missed these talks, the video for Abby Stylianou is available on our website, and the video for Colton Seal will be up shortly after editing. Upcoming speakers include on the 26th of March, Dr. David Mayman of Georgia State University, who will explore evidence-based cybercrime research, and he'll be interviewed by Ethan Burke, a George Mason student, one of our C3 intern alumni. He'll be interviewing Dr. Mayman in his capacity as the podcast editor for Sycamore Institute, the first foreign policy focused and national security focused think tank run entirely by college undergraduates. And then later this spring, on May 6th, we'll have Dr. David Kyle from the University of California, Davis. Dr. Kyle is a sociologist who studies transnational political movements, networks, and human smuggling. And he will talk about his concept of cognitive migration. For all of these events and access to our archives, please join our mailing list. Visit our website, first of all, at CINA, with a C, CINA.gmu.edu, and join our mailing list there for all of our announcements. I should mention that CINA is supported by a DHS board of directors, many of whom are on this call, and who help us to ensure the relevance of our research and identify champions in funding for transition. I would also like to mention that in addition to our cooperative agreement, CINA has a basic ordering agreement with DHS. It was recently renewed, and it can facilitate bespoke research, which can go beyond and can be more applied than the research that we fund under the cooperative agreement. And if you're interested, our transition and impact manager, Stephen Self, can help set you up. So without further ado, let's get started. Let's hear from Dr. Ma and Dr. Chung with Adaptive Graph-Based Framework for Multi-Source Digital Forensic Analysis. Dr. Ma, take it away.
Thank you. Thank you so much for the nice introduction and to the overall introduction of CINA. So my name is Yao, and I'm an assistant professor at RPI. And so we also have co-PI. Lou, do you want to introduce a little bit about yourself quickly before I? Right. Okay. It seems so Lou's mic is disabled. So Lou's also an assistant professor in at the University of Illinois, Chicago. So we will be working on kind of dealing with multi-source digital forensic analysis, utilizing graph-related techniques, specifically graph deep learning. All right, so let me quickly introduce. This is the major agenda. So we will first introduce the challenge, and then a quick overview of the project and also the technical approach. And then I think we will quickly introduce the application and potential stakeholders. And also we will quickly discuss our transfer plan, right? So our project is actually trying to address the issue of challenging in dealing with multi-source data. So I think in digital forensic data are always a multi-source. We might be dealing with data from many different sources, different data dumps, different kinds of data, such as accounts information on different devices, different login, and also potentially transactions, also kind of email. So there are a lot of different data from different kind of resource sources. So what we want to do is trying to correlate this data and mine important information from them. And so the major challenge is right now, I think we existing tools didn't try to do them in a quite efficient way. And we want to somehow improve the efficiency and also try to kind of provide some explainability and interpretability about our findings. And so these are the major research challenges we want to address. So what we want to do, the key research question we want to handle is the first one is about how we can somehow utilizing graph-related correlation models to uncover the hidden relationships across multi-source forensic data. Of course, before we uncover the hidden ones, we will use the explicit one as well, right? And the next one is after we kind of build such relationships, how can we utilize these relationships and with the help of AI methodology, how can we try to improve the cybercrime investigations? And after all, we also want all our analyses with good explainability and transparency, so that the expertise, when they use these tools to do the analysis, they know why we come up with the results. All right, and so here's a quick overview about our project and about what we will do. So again, we want to kind of utilize AI tools, especially graph-based tools to kind of automate the forensic analysis, especially for multi-source data. So what we will do is first of all, we want to construct a graph-based forensic knowledge base. So specifically given a piece of data, we want to build a graph connecting different artifacts different events together. And then we also want to mine hidden relationships among those kind of artifacts. And then we want to develop like an AI method to do anomaly detection in this piece of data, trying to find like some abnormal events, and also find potential crime in some sense. And at the same time, we want to provide interpretability as well, right? So the expected impact includes a more intelligent and automated solution. And also we try to make sure this one is somehow more efficient, can enable fast crime detection. And so especially because it will be automated, we expect it can also handle a larger scale data sets as well, to enable somehow to deal with a more large volume data at the same time. Yeah, and so this is the overview of our project, and here is a quick dive into our technical approach. So again, following what we have discussed, the first task we will be dealing with is to kind of build a graph based on the forensic data from multiple sources. We want to build such a knowledge graph to connect the data or entities in the data. And then, of course, we also want to develop some algorithms to mine the hidden relationships to uncover indirect links. All right. And the second task will be somehow utilizing deep learning models for graphs, specifically graph neural networks, to do anomaly detection on the graph we just built. Right. So this is to identify suspicious patterns from this data. And after all, the third task is trying to enable interpretability, and also kind of make sure that we provide some explanations for our results, so that the experts can more easily use the tool, can understand what the model produce. Right. So I think our tool potentially if we so our tool can be utilized for many different scenarios and stakeholders. And here I just list some of them. I think majorly this will be, of course, be utilized for forensic investigations, right? Digital forensic investigations, and of course it can be utilized to find the cybercrimes, and even insider threat detection, to kind of detect abnormal or suspicious logins, unauthorized data transfers, for example. All right, so it could be utilized by different multiple stakeholders, including the cyber crimes center, and also of course other private sector cyber security analysts. So I think we were thinking these stakeholders could probably get involved to the research by providing some feedbacks once we develop a prototype. If we develop a real world tool, a tool, then we were thinking potentially, I mean, the stakeholders might try to utilize these tools on potentially real world data, because somehow we were not able to access kind of first-hand data. So providing feedback might be a good way to potentially help further improve these methods. Yeah. And here is a quick overview of our transition plan. So I think we will take about 10 months to build our framework, build our model, and so we try to somehow provide a prototype after this period of time. And then after that, we were thinking about potentially we can demonstrate what we have done. We can probably provide a demo and then engage with the stakeholder to try to check the solution and gain some feedback. And then we were thinking about to further improve the entire framework and the model after we receive some feedbacks. This is basically the plan for the first year. And then, I mean, I think we will continue this process to the second year. And then, after further improvements, we were trying to kind of further improve this model and also open source this tool we developed. And we were looking to do a transition do this a transition to the commercialization at the end of the second year. All right, I think that's all we have for the technical part and the project. So I do have some questions about how we might engage with the DHS, especially of course I think for the first stage we will kind of just be developing this framework or the model by ourselves, but after that my questions are more related to somehow how we can engage or how we can kind of collaborate with a DHS or other stakeholders.
Yeah. Thank you very much, Yao. Just a clarification that while the research is being conducted, and this is for our audience as well, just a reminder to the research team that under the terms and conditions of the cooperative agreement, there is no data sharing between DHS and the researchers. That's in order to make absolutely clear that the researchers are not engaged in any law enforcement activities. So to be clear, the reason why our research team doesn't have access to real world data is precisely because of those terms and conditions. It's at the point of transition, and this is often a challenge with transition. We need to introduce the tools to our colleagues, our stakeholders, and then allow them to test them internally using their data. So just to kind of level set for the whole group, to understand kind of how that collaboration can work. We do really very much encourage DHS stakeholders to be engaged right from the beginning, because that transition point where we move from publicly available or curated data sets or artificial data to real world data is the easiest point of failure in transition. And so having DHS stakeholders with us right from this kickoff, right through the milestones and to the point of transition is the best way to ensure that they are ready to receive the results of your research. Okay, great. I'll let you get back to your questions.
Oh yeah, thank you. Yeah, that's also somehow what I thought. Probably it's more instead of we receive the data, it's more we share the model, right? We share the model with DHS, and they can utilize it. They can check it out. Yeah, so I think
there can be an iterative process where they check it out and then they come back to you, particularly while the project is ongoing. For advice, for adjustments, they can provide guidance on what's most useful. That's the genius of the COE model, that you can have this iterative and open conversation with the people who are going to use your tools.
Sure. Thank you so much. Yeah, I think most of my questions are related to the transition or the interaction with the DHS. Essentially all these 4 questions are related to the transition. Yeah, how we can interact with DHS. The last one is more how we can share the model in some sense. We can of course deploy it in the cloud or just make it just share the model directly. Yeah.
Terrific question, and one that I think will emerge sort of as you get closer to transition. But why don't we open it up to comments and questions from folks in the audience?
So if no question for now, so yeah, sorry, I wouldn't be able to like talk because of the mic problem. Yeah, hi everyone, my name is Lu. I'm the co-PI on this project. So I just would like to add one more thing about our plan regarding year 2. So in addition to the transition part, because we cannot really see the real world data look like, so I think what we are going to do as well in year 2 is also to study the robustness of our developed models. So hopefully that our models, in addition to like to make sure it can be can perform well on the data that's similar to our training data, but also of course we want our model to be also very robust to unseen data. So that I think that will be very helpful for the transition.
Yeah, thank you, Lu.
Great, and just to clarify for our audience who might not quite understand our funding cycle, the proposal, we welcome proposals for 2 years, but funding for the second year is contingent on satisfactory performance in the first year and also availability of funds.
Yeah.
Great, I have a question for the team. So how does the graph-based forensic framework differ from existing forensic tools?
Oh yeah, I can answer this question. I think like the major difference is like we try to kind of like build these like relations explicitly. So the framework would somehow like deal with the like relations or correlations between these data in a more efficient way. And based on this like graphs, I mean by correlations, I basically means like we will make connections between like different entities or artifacts, different activities, so that we can model this kind of like events, and we can utilize like state-of-the-art like graph learning methods to try to mine, like extract information from it. So yeah, so I think the connection part is like a quite an important thing, like compared with like existing methods, and of course like by utilizing like AI methods, we try to kind of like make it like a more automatic so that we can deal with like a larger scale data. And at the same time, as I think we introduced like throughout the way, the important thing is like we also try to introduce some explainability or interpretability, so that like our results can be more easily understood by the experts who are using this tool. So that like they can they don't need to like feel this like a black box without like clear like indications like why like the like the model is like suggesting some kind of like say like some abnormal events, so they will somehow like more easily understand like what the model is providing. Yeah.
That's so important these days, and particularly for folks in government. Okay, any other questions from the audience? Okay, I'll ask another one. How do you ensure reliability and interpretability of AI-driven anomaly detection in forensic investigations?
Yeah, I think Lou, probably you could like answer this one.
So the question basically is how we can make sure like the anomaly detection part and also the interpretability part, right? Like the basically the technical part. So yeah, for anomaly detection, so basically we're going to leverage some existing. First of all, the starting point would be to leverage some existing tools like GraphBeam. It's a existing tool that for anomaly detection on graphs. But I believe that because our model, our data sets are multi-source and multi-modality. So that will be a starting point. And then our goal here is to how we can, from that starting point, how are we going to develop a more advanced methods or effective methods that can detect anomalies. And the other part about interpretability is what we propose in the proposal would be is the concept bottleneck models. So basically, instead of so concepts are a more human-friendly explanations. So imagine that in computer vision or given an image, so kind of traditional type of interpretability methods like Shapley values, they give the importance values regarding the pixel levels. But for humans, right, for some domain experts who don't know much about AI, probably we don't really care about what are the pixels that are important. We care about what are the concepts that are important. So it can be interpretable to us, right? So I guess this would be applied also to the for our project. So basically, in addition to like defining out which evidence is important, probably we also want to know, like at a higher level, like at concept level, how the different evidences they can connect or correlate with each other, and then a specific event that will be really important or can be attributed to the digital forensics analysis instead of just think about individual evidence. So yeah, so I think that will be the key ideas behind our project.
Great, thank you very much, Lou. So Richard Putnam asked, how do we get the code so we can test? So we here at CINA are your go-to source to transition any of the outputs from the research project. So remember, this is Kickoff. It's just starting. The team has some ways to go before they have code available for you. But when the time comes, we would be happy to make it available to you. We have in the past done things like had teams put code on GitHub, and our government partners have downloaded it into test environments. That's one possibility, but there are plenty of other ones. I think the key point to know right now is that this is your research. So in terms of the U.S. government retains what's called a non-exclusive use right to any of the products of this research. It means that you don't have to pay anything for it. You can receive it on demand. It's also available to everybody else. It's not exclusive to any particular stakeholder. And by getting in sort of on the ground floor right now, you can also shape the development of the code and provide guidance, get early results. We'd be happy to give you a briefing whenever you like. We could also, we have had sponsors express interest in joining monthly meetings, monthly team meetings, but we could do it quarterly. We also have regular midterm reviews that we advertise widely. We'd be happy to have you join that. And we're always looking for feedback so that we can ensure transition at the end. Great. Okay, so we are at 2:30. We try to keep these kickoffs very tight so that we don't waste your time. But the kickoff has been videotaped, and we will make it available. So if you have a colleague who wasn't able to join today, please just check back with us. We will also be sending that link out. And we'd love it if you could share it with your colleagues and spread the word about CINA's work and about this particular project. And with that, I will thank Lou and Yao. Thank you very much for joining us and for getting this exciting work underway. And we'll look forward to hearing your progress. And thank you to all our stakeholders.
Yeah.
Okay, thank you, everybody. Have a great afternoon.
Thanks, guys. Good brief.
Yeah.
Thank you. Thank you so much. Bye.